Pre-calc guys, second part of parent functions. Just a reminder, parent function is the simplest form of a function. I'm going to go through real quick and show you a visualization of what parent functions look like. Give me one brief moment. I'm going to change the resolution on this camera so you can see it real clear. It should be better. Okay. The first one, if I can, let's see if I can zoom in a little bit more. Yeah, there we go. All right. So you should be able to see this a little bit better. All right. So we have the first one. It's a constant function. Y equals 3.5. That's what this one shows here. Just a horizontal line. We talked about it before. The second one, the identity function, or what we know of as a linear function. Okay, and that's what a linear function looks like. The quadratic function, that's the f of x equals x squared. That's our parabola. Okay, f of x equals c. So forgot to tell you f of x equals x. F of x equals x squared. And then the cubic function, right? That's the one that is a tweaked parabola. F of x equals x cubed, and makes that little turn and goes back up. Then we had other functions as well. We had the square root function. F of x equals the square root of x, and that's just half of what we think of as a parabola, and that looks like that right there. Everything starts at the origin. Okay, the reciprocal function is just f of x equals 1 over x, obviously the reciprocal of x, that's why they call it the reciprocal function. This has a couple of asymptotes, all right, and we get used to seeing this. And when we talk about transformations with this one, I'm going to need you to be able to visualize something, and it's kind of interesting the way it looks. But that's what the reciprocal function looks like. We have an asymptote at both the axes, because it never reaches 0 on either account. Sound good? Great. I'm going to move on to the next. The final two, if I zoom back up here, the absolute value parent function, f of x is the absolute value of x. It's our v function with a vertex at the origin. And then there was the last one, which is the one you had never seen before or probably didn't have a whole lot of work with, which is the greatest integer function with that crazy double bracket here. And all you did was you were given a value and you moved left to the next integer, right? You're looking for the greatest integer less than or equal to this value. So if we said it was 1/3, we go here at 1/3 on the graph and say, oh yeah, well 0 is the greatest integer just less than 1/3. Right? And so now we're going to start talking about transformations. And transformation has two forms. We have rigid transformations and non-rigid transformations. Rigid transformations means the shape stays exactly the same. The size and shape of your function does not change at all. We've just shifted it, either shifted it to the left or to the right, or we've shifted it up or we've shifted it down. Non-rigid means, hey, we've either stretched it or we've compressed it, right? And so that's the difference between rigid and non-rigid. And when it comes to non-rigid transformations, the shape doesn't look exactly the same. We've used the general same shape, but we've tweaked it in some way. All right? And now I'm going to show you what those transformations look like. I'm going to jump way up here to the top of the page to show some vertical translations. And these are rigid transformations. The translations are simple. Translation just means we've moved it up, we've moved it down, we've moved it over, we've moved it over to the other side. And they're pretty easy to see if you're just looking at the function itself. I'm going to write out the functions so that you can understand what it is you see. I have to look for my red marker and a green marker, and I'm going to make this work for you guys. All right. So I'm going to use black. They use blue for the parent function. If you draw the parent function and then you draw the different translations, you're going to be able to see what we've done to the function itself to see what happened. All right, we have added something outside the parentheses. So what's good to know is it's outside the parentheses. All right, outside the parentheses means we're taking care of a vertical translation. And I'm going to write down the parent function of this parabola. The parent function is simple. It's f of x is equal to x squared. Well, that's great. That's what that blue guy is. All right, well, we've added something to it. I'm going to say we've added 4 to it. So I'm going to show you what that function looks like written out. G of x, that's what that says, G of x is f of x plus 4. G of x is f of x, that's this, plus 4. Okay, well, we could also write it as G of x is x squared plus 4. Sound good? Great. And so we can just show what's going on there. If we look here, we've seen this is 1, 2, 3, 4 spaces up, and if it just so happened that we were going to shift it down, well, I guess that means we're going to subtract. So if we add some number to our function, a constant, a y-intercept as it were, we're going to shift up. If we're going to subtract, well, let's see what it looks like. This says f of x is x squared. That's our blue function in here. And so g of x down here, g of x is equal to f of x minus, let's say, 3. Looks like 3, right? 1, 2, 3. It could be 4. Could be similar. But let's say it's minus 3 for our purposes here. This also could look like this. G of x is x squared minus 3. Right? As long as it's outside, basically it's this, x squared minus 3. There's some parentheses there. And that's what this function looks like. Right? Now I'm going to move over here and I'm going to talk about horizontal translations. Well, if the translation or the addition or subtraction was outside the parentheses for vertical, we're going to talk about something that's happening inside the parentheses. Okay? So inside the parentheses, we have some subtraction here. I'm going to show you inside subtraction equals a shift right. And addition equals a shift left. Okay, and I could have written that in the different colors, but I didn't. Again, our parent function f of x is, again, x squared. We have our parabola, right? Okay, so now we have g of x, which is g of x, which is the same as f of x minus h. Uh-oh. Well, that looks different, doesn't it? And so we take this, we make it x minus h, and we square it, and then we have our shift over to the right 2 spaces, or 3 spaces. The same thing holds true down here. We take our original function, and we say g of x, in this instance, is the same as f of x plus h, and then square that if we wanted to write the actual function down. But this makes us go back here, and every time we see x, we put in x plus h. Okay, that's what this tells us. We go back here, and every time we see x, we put in x minus h. And that shows us a shift to the left. I hope you understand that. This is for our left and right, and our up and down, right? Our vertical and our horizontal. And so I'm going to move on to something a little bit different. Actually, if you don't mind, I'm going to take a look at some functions. And you can pretty much see, if I erase this, give us some room to look, we can look at these graphs, or we can look at these functions, and then look at these graphs, and understand what's happening to the graph itself. If I look at g of x, and its parent function is right there, right? That's the absolute value of x, and that's this guy down here, absolute value of x. And then we add 4 to it. Well, if we add 4 to it, just like it says here, that just means shift it up 4 spaces. And then the function remains the same, like it's got the same slopes on either side, right? It just has a vertex at positive 4 instead of having a vertex at the origin. Here, inside the absolute value symbol, we've added a 3. Okay, we have the addition of 3. Well, that's what it says here. This says that what we're doing is we're going to shift that parent function, f of x equals the absolute value of x, that v function, and we're going to shift it over to the left 3 spaces, and that's what it shows here. And last but certainly not least, we've got a double shift here, right? We've got a shift to the right, and we've got a shift down, right? To the right 2 spaces and down 1 space. That's what it says. You look at the function, we try to figure out what the parent function is, and that would be f of x would be the absolute value of x, but inside the absolute value symbol means we shift horizontally, and outside means we shift vertically. So we come back over here, we start with our parent function. We start with the vertex of our parent function. This says we shift to the right 2 spaces, so we move over 2 spaces. It also says we shift down 1 space, and we put our vertex there, and the same function appears. And look, it goes parallel. It should run parallel to the other function that you have there, only shift it over and shift it down. Other than that, not a huge deal. This is our cubic function right here. It's our wonderful little, S shape or weird looking Z shape, right? It looks like this, and it cuts through the origin. And basically what you're going to do is you're going to draw a picture of it, and you're going to take a look at what's going on with this. Well, we've subtracted outside of parentheses, therefore we're talking about a vertical shift. And this new one, this h of x, and I'm going to highlight it in green, and we're going to just shift down 5 spaces, create a vertex there, and then create the same function. And while, I may not draw perfectly, I could just make it run, hopefully I can make it run parallel to the function that I have there already. I'm going to do h in red. I'll just show you a little bit of red. Hopefully I can get this red to work. I don't have another one handy. And then this is shifted, because it's inside parentheses, it's shifted over to the right 3 spaces. So we just put a vertex here, and we have our function. It's not drawn very well. That's what happens when you leave it uncovered for a little while. I'm going to move on to a different color and see if my purple will work. But I've just shifted over 3 spaces. The last one has a double shift, and that's the one I'm going to do in purple. It's shifted to the left 2 spaces and up 4 spaces. So first thing I'm going to do is move over 2 spaces. I'm going to shift up 4. 1, 2, 3, 4 spaces. And I'm going to make that my vertex. And I'm going to create my graph. Sound good? Should. Should not be very difficult. There they are. I think the last thing we need to talk about in terms of transformations of these functions is something a little goofy, a little different, something you haven't seen on a regular basis, but I need to jump to it. It's on the next page. There it is. If I scoot way up here, here it is, here it is. Okay. This is reflections over the x-axis and reflections over the y-axis. And again, we're talking about inside and outside of the parentheses. We won't see a whole lot of this, but it is indeed something that you'll need to see. So if we're talking about outside of the function parentheses, we're talking about reflection over the x. Reflection over x-axis. Axis. All right? And then if we're talking about some negative inside, then we're talking about reflection over the y. Inside, reflect over the y-axis. Okay? Should be pretty self-explanatory. We'll take a look at an example of it momentarily. We're going to just pull this down, and here we go. All right, outside parentheses, right? Outside, we've reflected over the x. Outside the whole shebang, it's still, oh, what's wrong with this? Well, we've reflected it, but we have some shifting going on too, right? So we've done a bunch of work, but we've also made this whole thing our negative. So what'll happen is you'll take this, right? This whole thing needs to be shifted to the right 1 space and shifted up 2 spaces. So the parent function is this, right? And then when you do this math, you have a picture that starts here, up 2 spaces, right? And over to the right 1 space, so it goes here. Well, then I have a negative outside of the parentheses, and okay, so if I'm 2 spaces up, I go 2 spaces down, and I recreate my inverted function because I've reflected this function, I've reflected it over the x-axis. Okay? I know it sounds goofy, but I have to do the work and find what this looks like without the reflection, find what this looks like, and then I can show the inversion of it. Okay? This, no parentheses, is just a reflection of itself. So we do with parentheses, without parentheses. So this is without parentheses, and this is with. Okay, and so what we do is we know what our parent function is. Our parent function is this, right? I know I'm drawing on top of it, but we take that and we say, okay, well, first and foremost, I'm going to shift to the right one space, and I'm going to shift up 2 spaces. So this function would look like this. All right, but outside with no parentheses, outside of that square root symbol, I have a negative, so I need to reflect it as if this were the x-axis. So I'm going to reflect it over itself. I'm going to show its reflection, and that's why it starts here. With the parentheses, I reflect over the actual x-axis. Without parentheses, I reflect over its origin. Okay? So without parentheses, reflect over origin, and its origin, where this starts. If we've translated it over and up, like we did, we reflect over itself. I guess we could say we reflect over itself. That's an even better idea. Okay, because if I write the word origin, it's going to mess everything up. With parentheses, reflect over x-axis, no matter where it is on our coordinate grid. I know that's a little bit steep and heavy for us right now, but I think you can handle it. And those are really all those reflections that we've done. The next video I'm going to post for you is a couple of the problems on our practice sheet, and then I'm going to move on, and then we'll start talking about the next part. Thanks so much for your attention, and I'm going to get to 1.5 practice, and I'm going to do some sample problems that look very much like what we have on our practice.